speakers, workshop trainers, and participants. I am Atika Islam, and on behalf of Rifa School of Computing and Innovation, I cordially welcome you to Day 2 of ICCI 2025. Before we begin the proceedings, we will start our program with the recitation of the Holy Quran. I would like to invite Mr. Hafiz Muhammad Rizwan to please come forward for the recitation.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم ألم تر أن الله يعلم ما في السماوات وما في الأرض ما يكون من نجوى ثلاثة إلا هو رابعهم ولا خمسة إلا هو سادسهم ولا أدنى من ذلك ولا أكثر إلا هو معهم أينما كانوا ثم ينبئهم بما عملوا يوم القيامة إن الله بكل شيء عليم ألم تر إلى الذين نهوا عن النجوى ثم يعودون لما نهوا عنه ويتناجون بالإثم والعدوان ومعصية الرسول وإذا جاءوك هيوك بما لم يهيك به الله ويقولون في أنفسهم لولا يعذبنا الله بما نقول حسبهم جهنم يصلونها فبئس المصير. Do not think that Allah knows whatever is in the heaven and whatever is on the earth. If three commits privately, he is their fourth. If five, he is their sixth. Whether fear or not, he is with them, whether they may be them on the day of judgment. He will inform them of what they have done. Surely, Allah has perfect knowledge of all things. Have you not seen those who were forbidden from secret talks, yet they always return to what they were forbidden from, conspiring in sin, aggression, and disobeying to the messenger? And when they come to you, O Prophet, they greet you not as Allah greets you, and say to one another, why does Allah not punish us for what we say? Hell is enough for them, they will burn in it, and but an evil destination. Sadaqallahul Azim.
Thank you, Hafiz Muhammad Rizwan, for the beautiful recitation. Now I would request everyone to please stand up for the national anthem of Pakistan.
चलेगा
Thank you. Please be seated. Once again, welcome to day 2 of ICCI 2025 at Rifa International University, Lahore, Pakistan. We are delighted to have you with us again as Lahore continues to shine as a vibrant hub of global collaboration where ideas and innovation come together. Rifa School of Computing and Innovation is proud to host brilliant minds from around the world. Ladies and gentlemen, RSCI is a leading center of excellence committed to high-quality education, impactful research, and industry-driven innovation. Day 1 successfully concluded yesterday, offering a blend of expert talks, practical workshop trainings, and a thoughtful panel discussion. Today's program highlights includes the 3-minute thesis, competition, engaging sessions by our workshop trainers, and insightful talks by our distinguished international speakers. As we move into day 2, I would like to invite our conference chair, Professor Dr. Muhammad Asif, to officially open ICCI 2025 with opening remarks. Dr. Asif is a seasoned academic and technology professional with over 17 years of experience across academia, the software industry, and research and development. He holds a PhD from KUST Islamabad with expertise in computer vision, video coding, and parallel computing. He has served in key academic leadership roles including Dean of FCS, Head of the CS Department, and Graduate Program Coordinator, contributing significantly to accreditation, curriculum development, and program development. With substantial industry experience in both the USA and Pakistan, Dr. Asif has worked on AI-powered surveillance, video compression, multimedia systems, and embedded solutions. Ladies and gentlemen, please join me in warmly welcoming Professor Dr. Muhammad Asif.
Bismillahirrahmanirrahim. Honorable Director RSCI, HODs, keynote and invited speakers, faculty members, participants, and dear students, Assalamu alaikum. On the behalf of Rifa School of Computing and Innovation, I would like to extend my great pleasure and welcome you all on the second day of International Conference on Computing and Innovation, ICCI 2025. The aim of this conference is to bring together researchers, academicians, practitioners, and industrial experts across the globe to explore the latest development shaping the future of computing and digital innovation. The program of ICCI 2025 has been carefully crafted to ensure technically rich and impactful experience. It comprises keynote speeches, invited talks, high-value panel discussion, and energetic 3MT competition along with hands-on workshops focusing on emerging technologies. Here in ICC 2025, we emphasize on industry-academia integration, in which experts from industries are invited and take their valuable input and participation in different segments of the conference. And we tried our level best to take their valuable input and how we can strengthen our degree program to uplift the standard of our graduates and how these graduates can be ready to serve the nation, or you can say that ready to serve the industry after the graduation. And we are honored to have a host 30 international speakers and as well as from local academia and local from different universities as well as from the industries. Yesterday we have hosted 8 talks including 2 international and rest are from the local top-notch universities of Pakistan, and as well as we also hosted 5 workshops in the domain of data science, in the domain of cyber security, as well as in the domain of computer vision and web development. And in the second day of ICC 2025, today we are going to host 22 international talks as well as 3 MT competition which is organized for the MS and PhD scholars, in which we are happy to announce that we have 40 participants from different universities of Pakistan, as well as a valuable number are added from the international universities. I am also share that ICCI 2025 is being held in hybrid mode, enabling both on-site and online participation to ensure global accessibility. All sessions are being live streamed on YouTube and Facebook. We hope that this second day of workshop provides you enriching experience in a simulating environment for scientific exchange, identification of emerging trends, and collaboration on the next generation technologies. Your active participation, whether in person or online, will enrich the dialogue and strengthen the collective impact of this event. Once again, we welcome you all to the second day of International Conference on Computing and Innovation. May this gathering inspire new ideas, meaningful partnerships, and a lasting contribution to the field of computing. Thank you very much.
Thank you very much, Professor Dr. Muhammad Asif, for your words. It is now my honor to introduce our keynote speaker, Professor Dr. Muhammad Shafiq. Dr. Shafiq is a global network professor at New York University, Abu Dhabi, and the NYU Tandon School of Engineering, USA, and an internationally recognized researcher in AI hardware, brain-inspired computing, and energy-efficient intelligent systems. With over 250 publications, international awards, patents, and leadership roles in major research communities, he is regarded as one of the leading voices in advanced computing and emerging technology. Ladies and gentlemen, please join me in welcoming Professor Dr. Muhammad Shafiq for the keynote speech.
Hi everyone, can I share my screen?
Sir,
Can you see my screen?
yes, sir, it's visible.
Perfect. I'm hearing my voice back, so please mute yourself, and I'm now starting. Okay, so thank you very much for the kind invitation. Thanks Asif for contacting me. Also, it's an honor to present our work at this conference at RIFA. So in today's talk, what I'm going to do is to present our work on energy efficient and security for the EdgeAI applications. EdgeAI is a very wide range of applications where we are integrating artificial intelligence, machine learning into end user systems. So I'll be talking about architectures, systems overall, what are the challenges, what are the different methods, and then the applications that we are developing in our lab. This research has been funded by various sources like Center of Cybersecurity, Center of Artificial Intelligence, Robotics, Center of Quantum and Topological Systems, and Center of Smart Cities at NYU Abu Dhabi. And this is the joint work done at different team members in my group in NYU Abu Dhabi and NYU Tandem. Without further delay, I'll just start my talk and give you an overall overview of the challenges. We all know that now machine learning or AI, like in general form, is kind of a de facto standard to process data to predict, derive short-term, long-term predictions. In various different domains that we call them in general smart cyber physical systems, because there is a cyber component and there is a physical component like automobiles, like robotics, as well as the complete cyber components like in our smart homes and healthcare devices. And when we have to implement these kind of systems, what we need very tight performance on extremely low power budget and extremely low energy efficiency. The applications are widespread, like we know that even in an autonomous vehicle or a smart autonomous mobile robot, there are like numerous number of applications which require deep neural networks or even large language models nowadays also on the robots, ranging from collision avoidance, lane detection, and things like that. And we all know that classification is a very saturated problem. It has been widely explored. The modern problems are related to segmentation and detection, and then of course, in terms of online learning and things like that. When we go further, we have seen that these applications can be in different domains like financial sectors, medical imaging and things like that, as well as also like medical clinical support systems and of course games are one of the prominent ones also. This is like a result from our recent project which is funded by the Multiple Sclerosis Society, where we are detecting the MS lesions in 3D voxel of an MRI image, and then we are also deriving the lesion growth and suppression over the period of time. This is typically called a longitudinal analysis, just to give you an idea that how valuable it would be, and this is very beneficial for the neurologists and neurosurgeons as well as radiologists to very quickly analyze the underlying diseases and issues in medical images. So in general, machine learning and AI can be extremely helpful. The challenges that we as designers face are primarily the resource constraint embedded systems, because many of the applications that we are building up are extremely tight in terms of size, computer memory, resources, and that's relative to the complexity of the modern ML applications. So just to give you an idea, this is an emerging trend of embodied AI, which basically means enabling advanced AI on robotics. Typically these are like called AI agents, and they have certain properties that make them things working in embodied form. For example, there is a wide range of perceptual inputs. So you have multiple different cameras as well as lidar and other kind of sensors. Through these sensors, these robots are perceiving the environment around them, what we call is a world model, which basically means they are building up an abstract representation of their surroundings, localizing them, and then they are interacting with the world, which basically means that it could even be a VLA, like vision language action kind of model, or it could also be an imitation learning based stuff, and they are interacting with the humans and they are learning on the fly, and maybe there's a reinforcement learning implemented on the loop for them to continuously learn different things, and they have a goal, and they are learning towards a goal. For example, you can give a command, hey Nemo, can you fetch me a packet of chips from the kitchen, and then the robot will automatically do the path planning, navigation. If the map is not perfect, then it will also build the map and then accomplish the task. Now instead of being explicitly programmed, it can also learn the policy itself, because the large language models, if they have sufficient amount of data trained, then they can also
generate the
for the
policy for
robot,
the robot,
and then
and
robot
the
can
robot
also
can
do the
also do the
reasoning that
reasoning that
why
why
it
it
has
has
to
to
take
take
route
route
one and why
1 and
not
why
the
not
route
the
two,
route
like
2,
we
like we
humans
humans
reason,
reason,
for
for
example, to find the
example, to find the
shortest path,
shortest path
or to
or
find
to
the
find
path
the
with the less
path with the less
congestion.
congestion.
So in
So in
general,
general, if you
that
imagine
there's
that
so
there's
many
so many
different type
different
of
type of
machine learning
machine learning
models running
models
on
running
one
on one
small
small
mobile
mobile
robot,
robot,
then you can
then you
already
can already
imagine that the
imagine that the
challenge of
challenge of
backing those
backing those
models under
models
low
under low
complexity is a big
complexity is a
challenge
big
again.
challenge again.
Um,
Um,
and of
and
course,
of
again,
course, again,
generative AI,
generative
pretty
AI,
much
pretty much
everyone, I'm
everyone,
pretty
I'm
sure
pretty
sitting
sure
in the
sitting in
room
the
already
room already
knows.
knows.
You guys
You
are
guys
already
are already
extensively using
extensively using
ChatGPT,
ChatGPT,
Claude, or
Claude,
other
or
kind
other kind
DeepSeek like
DeepSeek like
services.
services.
There are also
There are
video
also video
generation
generation
services like
services like
Soda, you know,
Soda, you know,
When,
When,
Midjourney,
Midjourney,
and
and
Runway kind of
Runway kind of
stuff.
stuff.
But
But
more
more
importantly, there are
importantly, there are
also
also
emerging
emerging
trends in
trends
code
in code
generation. For
generation. For
example,
example,
Cursor,
Cursor,
GitHub
GitHub
Copilot, and
Copilot,
those
and
kind of
those kind
stuff.
of
They're
stuff. They are
extensively being
extensively
used
being used
nowadays
nowadays
for
for
automatically
automatically
generating your
generating your
code
code
programs. And
programs. And
ChatGPT can
ChatGPT can
itself
itself
also
also
really good
really good
in code
in code
generation.
generation.
Claude and
Claude and
Quen
Quen
definitely are
definitely are
very
very
well
well
at the top
at
of
the
the
top of the
leaderboard in
leaderboard
terms
in
of code
terms of code
generation, and they're
generation,
very
and they're very
specific
specific
application code
application code
generation than the
generation
other
than the
kind of
other kind of
leaderboards
leaderboards
available.
available.
But what
So
really
what
is very
really is very
interesting
interesting
nowadays for the
nowadays for the
hardware
hardware
community is
community
the
is the
emergence of the
emergence of
large
the
language
large language
models to
models to
automatically
automatically
generate the
generate the
hardware code,
hardware code,
which
which
basically means that
basically
even
means that
if you
even
are
if you
not a
are
chip
not a chip
designer, you
designer,
can
you can
actually
actually
give your
give your
specification to a
specification
large
to a
language
large language
model, and it
model, and
can
it can
generate the
generate the
RTL
RTL
specification for
specification
you.
for you.
So
So
overall,
overall,
across the
across
different global
different global
sites, New
sites,
York
New York
University
University
one of
is
the
one of the
leading
leading
effort,
effort,
having
like
the
having
leading
the leading
effort in
effort in
automatic chip
automatic chip
generation
generation
using
using
generative AI
generative
tools
AI
and
tools and
stuff.
stuff.
And there is
And there is
also a
also a
wide
wide
range of
range of
interest
interest
from
from
different
different
companies
companies
like
like
Synopsys,
Synopsys,
Cadence, which are
Cadence,
the
which are
building
the
of this
building
thing.
of this thing.
So
So
eventually,
eventually, all in
if I
all,
want to
if I want to
summarize,
summarize,
there
there
is a
is a
lot of new
lot of new
tools
tools
coming up
coming up
which can
which can
solve your
solve your
problems very
problems very
easily
easily
nowadays.
nowadays.
What we are
What we are
missing
missing
is
is
actually ML
actually
AI
ML AI
engineering, which
engineering, which
basically mean
basically
that
mean that
how do you
how do you
use these
use
tools
these tools
efficiently to build
efficiently to
up the
build up the
larger
larger
system very
system very
quickly, how to
quickly, how
test
to
them, how
test
to
them, how to
deploy them.
deploy them.
And I think
And I
that's
think
where the
that's where
next
the next
generation of skill
generation of
set
skill
will
set
come.
will.
Having said
Having
that,
said that,
the
the
power
power
consumption
consumption
challenge is
challenge is
extremely
extremely
important to be
important to be
understood.
understood.
We already
We
know
already know
that
that
there
there
is
is
kind of
kind of
criticism
criticism
on
on
the AI
the AI
community that
community
they are
that they are
burning too
burning
much
too much
power.
power.
Even the
Even the
enterprises are
enterprises are
buying
buying or
acquiring different
acquiring
power
different power
grids.
grids.
There was an
There was
earlier
an earlier
study in
study
nature
in
machine
nature machine
learning that
learning
a
that
machine
a
learning
machine learning
model
model
actually can
actually can
consume
consume
more than
more
five
than
times
five
than a
times than
car
a car
actually that
actually
is
that is
consuming.
consuming.
And now if you
And now
look
if you
at the
look at the
latest
latest
trends, where
trends,
this was
where this
only
was
for the
only for the
transformer
transform
models, and now
models,
you
and
can
now
see
you
that
can
the
see that the
GPT-3
GPT-3
model,
model,
data center
data center
emissions using
emissions
Amazon
using Amazon
services, you can
services,
see
you
it's
can see it's
extremely high.
extremely high.
The
The
models are
models are
growing
growing
in terms
in
of
terms of
complexity and their
complexity and their
size,
size,
which means
which means
the
the
power
power
to
to
train
train
one
one
large,
large, for example,
GPT
GPT
model,
model,
GPT-5,
GPT-5,
GPT-4, or
GPT-4,
even
or
the
even the
latest
latest
versions
versions
is
is
extremely high.
extremely high,
And I think
and
we
I
just
think we just
cannot
cannot
imagine that
imagine
how
that how
large it
large
can
it
be.
can be.
And it's
And
not
it's
only the
not only
power
the
that we
power
are
that we are
spending
spending
in
in
training,
training,
but it's
but
also the
it's also
power
the
that
power
we are
that we are
spending in
spending in
inference.
inference.
Imagine
Imagine
training is only
training is
done by
only done by
enterprises, so they
enterprises,
can
so they
acquire
can
power,
acquire
they can
power,
buy
they can buy
everything,
everything,
or whoever
or
is
whoever is
building up their
building
own
up their own
foundation model,
foundation
they
model,
can
they
put
can
together
put
a
together
power
a
grid
power
and then
grid and
train
then
that.
train that.
But
But
imagine that there
imagine
is
that there is
90% of
90%
the
of the
systems on the
systems on the
planet are
planet are
actually edge
actually edge
devices,
devices,
and we are
and we are
using them
using them
massively in
massively in
inference.
inference.
So what,
So what,
how much
how much
power we
power
all
we all
collectively are
collectively are
consuming? So
consuming? So
we have to
we
be a
have
bit
to be a bit
cautious about
cautious
that
about
as
that
well.
as well.
Though
Though
power of a
power
single
of a single
device may
device
not
may
sound
not sound
very
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 high
high
to
to
you,
you,
but
but
there
there
is
is
a
a
significant. So
So
yesterday I was
yesterday I was
actually
actually
on a
on a
panel
panel
for
for
exactly the same
exactly the same
problem on
problem on
CO2
CO2
emission,
emission,
renewable
renewable
energy
energy
or
or
clean
clean
energy
energy
versus
versus
AI,
AI,
employment
employment
in different
in different
countries and
countries
stuff
and
like
stuff
that.
like that.
And
And
they're very
they're very
interesting
interesting
discussions that the
discussions that the
community is
community
these
is
days
these
doing,
days doing,
that
that
how do
how
you
do you
incorporate green
incorporate green
technologies
technologies
when, for
for
example, putting
example, putting
together a
together a
compute
compute
center
center
for
for
AI
AI
training,
training,
AI
AI
foundation model
foundation model
training,
training,
or also
or also
building up
building
the
up the
energy efficient
energy efficient
accelerators
accelerators
for
for
extremely low
extremely
power
low power
inference and
inference
things
and
like
things
that.
like that.
Now,
Now,
again, when
again, that
giving you an
giving you an
idea,
idea,
ResNet 50,
ResNet
which
50,
was
which
a
was a
milestone in
milestone in
image-based
image-based
classification,
classification,
Megatron, which was
Megatron,
one
which
of
was
the
one of the
earlier
earlier
generation of
generation of
really
like really
transformers.
transformers.
It was
It was
more than
more than
2000x
2000x
complex.
complex.
In
In
ResNet, it was
ResNet,
already
it
in
was already in
2019.
2019.
Within 2
Within
years,
2 years,
GPT-3 was
GPT-3
already
was already
90,000x,
90,000x,
and within
and
one
within
to two
one to
more
2 more
years,
years,
it's already
it's already
orders of
orders of
magnitude more
magnitude more
complex than that.
complex
So
than
if you
that. So
look
if
at
you
this,
look
this
at
is a
this, this is
super
a super
exponential
exponential
complexity at which
complexity
we
at
are
which we are
going.
going.
In that
And
side,
that
we can
side, we
already
can
see
already
that
see
after
that
ResNet
after ResNet
50,
50,
the
the
training
training
actually got
actually
out of
got
the
out
hand
of
of
the
a
hand of a
normal
normal
person.
person.
Even
Even
training a
training a
transformer using
transformer
a
using a
NAS,
NAS,
no one can
no
use
one can
because
use
you need
because
to
you need
really
to
do
really do it
extensive
extensive
NAS for
NAS
that
for
to get
that
to
to
the
get to the
optimal model.
optimal
This is a
model,
neural
which is a neural
architecture search.
architecture search.
So
So
this
this
basically
basically
means
means
that
that
the
the
modern
modern
trend
trend
is
is
basically
basically
the
the
foundation
foundation
models or
models
the
or the
advanced
advanced
ML
ML
models are
models
built
are
by the
built by the
enterprises,
enterprises,
and
and
the
and
smaller
the smaller
companies or
companies or
the smaller
the smaller
organizations are
organizations are
primarily doing
primarily doing
efficient fine
efficient
tuning
fine
and RAG
tuning and RAG
systems
systems
to build
to
up their
build
own
up their
systems.
own
So that's
systems. So
where I
that's
call
where
the
I call
AI
the AI
engineering is
engineering is
extremely
extremely
important
important
nowadays.
nowadays.
On the other
On the
side,
other side,
there are
there are
also a
also
lot
a
of
lot of
improvements in
improvements
the
in the
underlying
underlying
hardware
hardware
architectures.
architectures.
Our
Our
GPUs are
GPUs are
getting better
getting
and
better
better
and
with
better
every
with every
generation.
generation.
If you look
If
at
you
the
look at
modern
the modern
GPUs
GPUs
landscape, they are
landscape,
having
they
a
are
lot of
having a lot
tensor
of tensor
cores,
cores,
which are
which
very
are
different
very
from the
different from the
traditional
traditional
GPU
GPU
cores,
cores,
that threaded
that
cores that
threaded
they were
cores that they were
having.
having.
And now that
And now
even the
that even
tensor
the
cores are
tensor
in the
cores are
low
in a low
precision, like
precision, like
8-bit,
8-bit,
4-bit kind of
4-bit kind
stuff.
of stuff.
Cerebras
Cerebras
released one
released
of the
one of
world's
the
first
world's
wafer
first
scale
wafer
chip,
scale
where they
chip,
have, I
where they
think,
have, I
reached
think, reached
generation 2 or
generation 2 or
generation 3
generation 3
already,
already,
which is
which is
much
much
larger than a
larger than a
GPU. And what
GPU.
it
And
does
what
is
it
that
does is that
instead of
instead of
communicating across
communicating
multiple
across multiple
GPUs, you can
GPUs, you
actually
can actually
offload
offload
the
the
training
training
on these
on
kind of
these kind of
stuff.
stuff.
Now,
Now,
effectively, if you
effectively,
look
if you
at
look
the
at the
autonomous systems
autonomous systems
community
community
challenge,
challenge,
what they are
what they are
striving for
striving
is
for is
basically
basically
to put
to
together
put
a
together
brain
a
in a
brain in a
robot or in
robot or
any
in
kind of
any kind of
autonomous
autonomous
system,
system,
but that
but
chip
that
should
chip should
not
not
consume more
consume more
than
than
a human
a
brain
human
if you
brain
want to
if you
get the
want to get
same
the
type of
same type of
learning.
learning.
Although the
Although
chips
the
that we are
chips that we are
typically
typically
inserting due to
inserting
their
due to
cooling
their cooling
factors
factors
typically
typically
operate in the
operate in
range
the
of
range
few
of few
watts.
watts.
Below 10
Below
watt is
10
the
watt
ideal
is the
one. But
ideal one.
even
But
if you
even
want to
if you want
go
to go
and we say
and
that
we
we
say that
want
we
to
want
be
to be
as
as
intelligent as
intelligent as
humans, and we
humans,
are
and we
very
are
good
very good
in
in
progressive
progressive
learning,
learning,
which the
which the
modern ML
modern ML
systems are
systems are
not,
not,
then we only
then we
need to
only
do
need to
that
do
in
that
20
in 20
watts, while
watts, while
these
these
data
data
centers are
centers are
actually
actually
requiring a
requiring
full
a
power
full power
grid.
grid.
So there is
So there is orders of
at least
magnitude,
three
at
to
least
four
3 to
orders
4
of
orders of
magnitude
magnitude
efficiency
efficiency
gap, and
gap,
that's
and
great
that's
news
great news
because in
because
general
in
which
general,
means a
which
lot of
means a lot of
research and
research and
development
development
challenges,
challenges,
and there is a
and
lot
there is
of
a lot of
research that has
research
to be
that has
done
to
in
be
order
done
to
in order
really
to
build
really build
true
true
autonomous
autonomous
systems
systems
which can
which can
think
think
and
and
operate at the
operate
same
at the
power
same power
envelope.
envelope.
Now,
Now,
just to give you
just
a
to give you a
few
few
future
future
science kind of
science
stuff,
kind of
I think
stuff,
the
I think the
future of
future
AI
of
is
AI
very
is very
bright.
bright.
If you guys
If
are
you guys are
pursuing your
pursuing
career
your
in
career
AI
in
and
AI
machine
and machine
learning,
learning,
there is
there is a
plenty of
plenty
job
of
which is
job
going
which
to
is
be
going to be
created in
created in
future.
future.
And the reason is
The reason is
because
because
pretty much
pretty
every
much every
company is
company
now
is now
stepping into
stepping
that
into
how
that
their
how their
services can
services
be
can be
made
made
advanced using
advanced
machine
using
learning
machine
and
learning
stuff
and
like
stuff
that.
like that.
So
So
Stargate, I think
Stargate, I
pretty much
think pretty
everyone
much
knows this
everyone
is
knows
one
this
of
is
the
one of the
largest
largest
initiative which is
initiatives which is
done
done
started by
started by
US. Many
US,
different
many different
enterprise
enterprise
NGOs like
NGOs like
OpenAI,
OpenAI,
Microsoft,
Microsoft,
NVIDIA have
NVIDIA
joined
have
hands
joined
in that.
hands in that.
And the
And the
Stargate has a
Stargate has a
UE
UE
version,
version,
also because
also
there's a
because there's
massive
a massive
investment done
investment
by
done by
UE. So
UE. So
US UE
UE
Stargate
Stargate
initiative
initiative
is
is
actually
actually
going to build
going
a
to build a
strategic
strategic
electrical
electrical
infrastructure, which
infrastructure,
basically
which
means
basically
that
means
there
that
is
there
a
is a
lot of
lot of
application of
application of
machine learning and
machine learning and
AI
AI
being deployed in every sector here, and there is a strategic agenda that in general we want to become the AI leading company, which is great also because it's very close in vicinity in Pakistan, and a lot of companies are stepping into the financial sector here as an external entity, and then there's a great potential to grow in terms of entrepreneurship also here. Now, having said that, performance and performance and energy efficiency are two very important stuff, but when you want to deploy them in your systems, robustness is another key point that we have to look into. And in that term, the security, safety, validation, all these are very important goals. So if you look at this, these are like some of the crashes which have been reported for the earlier generation of the autonomous vehicles, and there is also this hacking of the mobile phones which was done by showing these pictures or showing the masks. And I just want to show you some of the videos. I guess that's easier. If you look at this video, you can already see that this is the Tesla black box and the Tesla car, and then they just ran a black box attack. They're showing a random image to the car, and suddenly the wiper control system of the car is activated. Here they have put three different white patches, and then the car suddenly when the autopilot was activated, it deflected. It thought there is some object in front of that, and so when this thing was done, it rattled the community that anybody can buy any autonomous system and then can fool into that and then deploy those attacks in the physical world. These perturbations are called physical world perturbations, and they can create a lot of issues. Recently, a very powerful attack called phantom attack was done, in which someone can actually project something using micro projectors, and then it can fool the Tesla car or any kind of autonomous vehicle or mobile remote also. Here they have projected a stop sign on the advertising screen, and suddenly the car was stopped in the middle of the road, in the middle of the night, and this is also very dangerous. And when they remove this thing, then it starts working. So what a phantom attack shows actually that you even don't need to perturb the physical environment. All the physical environment perturbation is very easy because we have billboards, we have signboards, we have lot of other kind of screens, and you can show nice artistic patterns which embed an adversarial noise and control the system. But you can actually do this by using a projector also, and then don't leave a trace of that thing. So how do you design robust machine learning algorithms which are kind of attack proof? So this is a truly great question, because there have been so many different attacks which have been introduced at training time, at inference time, model seeding attacks, and someone has to defend against that. And this is one of the big areas where our lab has been actively looking into and then working on the practical prototypes that we are building up. So having said that, these were the challenges. Then of course there are a lot of other challenges that the overall AI community is facing, and I'm not going through all the challenges, but the ones which are relevant for at least the primary research projects that I'm going to present today. So I did that. So my lab actually is working across the full system stack. We have teams which are working on developing hardware accelerators, deploying them, securing them using logic locking. We had a project with one of the large industrial chip manufacturer on reliability of these kind of chips, and then how do you basically ensure that the machine learning models can run reliably on the chips which have faults. And these are very common when you're building your own chips, and some parts of the chip are not working, or they're like in critical systems. There is a software errors, like even if they, for example, you have a jet pilot, a plane or a car, they are kind of seen as critical systems. Or if you are deploying these kind of chips in any airborne systems or nuclear plants and things like this, then there's a lot of softwares happening, and how do you ensure that they are like really error-proof kind of stuff. Security is one of the main concerns of many of these things. I mean, healthcare also has a lot of stuff, but mostly at the moment community is concerned about the mobile robots kind of stuff. For example, someone can fool your quad rope, someone can fool your autonomous vehicle, someone can fool your UAV or UGV. So how do you ensure that those things cannot be hacked into, even using a black box model, and you are not even sure that if the answer you are getting is correct or not. And efficiency, as I said, is the first class citizen in designing these systems, which basically mean that you need to develop intelligent model compression tools like pooling, quantization, hardware awareness, to make sure that your models are actually practical and deployable on the real world systems. This has led to the whole domain of EdgeAI, tiny ML, tiny LLMs, and all those kind of stuff. And ultimately, we work towards the low power optimizations down to the circuit level, to all the way to the architecture level also. And then we are building up the full-scale applications, like we have the in-house build of the full ADAS pipeline, which is advanced driver assistance system. That is also the embedded perception pipeline of any mobile robot. We are building up other kind of machine learning models, even also for the emerging area of the quantum computing, we are doing RTM code generation, we are doing neuromorphic continual learning, we are doing a lot of stuff. So I'll give you a sneak preview of some of the methods, and then depending on the time, I can give you a little bit overview of demos of some of the demos that we have built in our lab, and we are showcasing to our industrial partners also. So the ultimate goal of my lab is to do innovative research and bring it to reality, where we are building up TRL4, TRL5 prototypes, and then showcasing it to our external partners to hopefully do some startups or licensing and things like that. This is the overview of my eBrain lab, where most of my researchers are sitting and doing innovative research on machine learning models and design methods. This is the embedded systems lab, where students are doing hands-on work, building a lot of engineering kind of things. And this is my intelligent coordinated autonomous systems lab, where we are doing the full system prototyping. We have a lot of different kind of mobile robots, humanoid. We have Aloha, which is like used for generating the data sets for imitation learning. We have like really big scale tank with mobile manipulator, which is used in many different industrial and agricultural kind of domain. We have fully scaled down autonomous vehicle kind of prototypes, and we have a lot of small prototypes of the UGVs and a full scale down track of autonomous vehicle and stuff like that. We have several quad road and 3D fabrication facilities. Small one and a large one is already available under the CTP in the university. Like just to give you an idea, you can see that some of the just very simple robotic stuff that is working on. Here the arm can pick the bottle, can do the operation. The humanoid can actually do walking. Stabilization is done using reinforcement learning. It can maneuver through autonomously in the corridor. The dog can also do a slam, and then localization, can do collision avoidance. And there is again a full stack working on. This is LiDAR based, but we are moving towards a full camera based systems because we want to deploy this whole pipeline on a small scale autonomous systems also, where the LiDAR cannot be deployed. So thanks to NYU, we have a lot of facilities, a lot of funding to procure these kind of stuff. We have practical test spaces to work into this thing. And if you want to scale up your research, then we have the Kinesis lab, where we can do the large scale experiments also. And we have a full playground where we can even test our drones and things like this. So in general, overall, I think there is a great potential to test, deploy our research and see that what are the actual environmental factors which can affect that. So having said that, now let me give you a very fast overview of some of the scientific methods, because that would be now important for the audience which is interested in deep down. So for the energy efficient architectures, we are building up our own neural accelerators. We have already two versions of different neural accelerators. This is a massively parallel neural accelerator which has different type of processing areas. It is definitely built based on systolic array-like architecture with different bypass modes. We have developed tools which can partition the processing of machine learning and then do the mapping of that. We have demonstrated that our CNN accelerators actually, which is quite older now, or is already like 2x faster than the state-of-the-art accelerators. We have also built up the capsule accelerators, but now capsule networks are not that prominent, so the transformer is a de facto kind of, in many of these applications. So we have built one of the world's first open transformer accelerators, which is completely fixed point kind of implementation, which also got in news. And this is based on again a massively parallel computer array. We have multi-headed self-attention block and different type of like Mac units. So these are like comparisons that I can share the slides. You can have a look at this, and we have shown that we have built it on EdgeAI 65nm technology, and our 6-tron architecture, for example, is completely integer rate based, and then it can be like much better compared to many other state-of-the-art accelerators which are available in the market. It provides an extremely high throughput, 3 to 4x faster than the recent, at that time, whatever GPU was there, compared against that, and it definitely consumes, instead of like 250 watts, 200 watts, it only consumes 33 watts, and the accuracy of the transformer model is very, very high, and we have tested for different type of transformer models also. So having said that, compute optimization is only one part. since I have extensive work in overall system architectures, we have always advocated that memory optimization should be one of the primary things that one should target. And in fact, memory and compute goes hands in hands, which means that if you are building up a massively parallel computer architecture, you need to design your memory hierarchy also accordingly, which can feed the data in the right fashion, which can shuttle the data from the off-chip memory to the on-chip memory and all the way to the compute elements, and which can massively reuse the data to avoid the excessive off-chip accesses, and this can significantly cut down your memory energy. Depending upon the architecture, the memory power can be 60 to 80% of the total power consumption, which means this is a big rock that you have to also break. So we have developed an off-chip memory optimization tool where we can extensively reuse the input feature map, intermediate feature maps, and a lot of weights. We have also developed an efficient tiling mechanism and mapping on the DRAM in multi-bank DRAMs or sub-array level parallelism DRAM. These are like two large DRAM organizations which are available, and we have shown that we can save up to 96% of the energy delivery product at DDR3 or SAL, which is a sub-array level parallelism architecture. And these are like all accepted at the top tier conferences and journals, which show that the community is very much willing to that. There is another thing which is called scalable effort computing, which basically means that you can actually change your underlying hardware to tolerate some of the errors which nobody can see actually in real life, and while getting a lot of energy saving. This trend is called approximate computing. There is a wide range adoption by industry and academia, and this research, this is almost no more than 1.5 decade. We have extensive work for almost a decade in this area. We have built dedicated tools which can do the model compression as well as the resilience analysis of different approximations and their impact on for example, the neurons accuracy. We have developed also different type of number formats and build up the full-scale architectures. We have also developed self-curing blocks, which basically mean that if you introduce a plus one error, then the next block will be giving you the -1 error, and the net error will be 0. And when you deploy them in a multiply accumulate, and if you're doing an FIR filter or any kind of MAC operation, you know that the goal should be the net error should be close to 0, which basically means that you are giving approximately correct answer with an extreme energy efficiency that you can have. Just to give you an idea, this is a older result. We have, of course, this is, as I said, pruning and quantization defect estimate for everything. So all the things that we deploy, we do pruning and quantization. So the later demos that I will be showing you for the modern systems, they will be doing all these methods. But just for the sake of simplicity and explainability, I have taken a very small example of an earlier version. And just to show you that there is a potential to actually cut down more than 90% of the neurons, which are not really relevant for your that particular use case, and you can retrain that network, and then it can still function very good and close to the top one accuracy that you were having earlier. So the quantization is also again a de facto standard nowadays. Nobody is working in floating points kind of stuff. You can go up to 16-bit fixed point quantization very easily. Then if your system has resilience, you can go up to 8-bit or up to even 4-bit. And then even there are people are using like mixed kind of quantization, which basically means that some layers, intermediate layers, which are not that important, you can have 4-bit quantization, and the starting layer and the final decision layer, which are like good, you can have 16-bit to 8-bit quantization depending upon the general resilience of the network and how well you have trained. We're talking about the post-training quantization, PTV kind of stuff, but there are also people who are working on like, you can aggressively quantize and retrain, or you can introduce quantization during the training process, or you can actually introduce pruning and quantization during the neural architecture search process, and all these different variants are available, and they are like widely used nowadays worldwide. And of course hardware approximation gives some extra bit of that energy savings. This is our in-house built complete neural architecture search framework, which is hardware aware, which basically means that you can tell me, Shafiq, okay, here is a mobile phone and here is my network specification that I want to solve this classification or detection problem. Can you please generate me a neural network which can fit into this device and then meet my goals? And answer is yes. And this is
And
done
this is done
typically by
typically
neural
by
after
neural after
research. What we
research.
do
What
is
we
that we
do is that we
define
define
different
different
basic building
basic building
blocks. We do
blocks. We do
permutations
permutations
to
to
build
build
millions of
millions of
candidate
candidate
solutions from
solutions
that
from that
block,
block,
and
and
then
then
generate those
generate
candidate
those candidate
solution and
solutions and
evaluate them
evaluate
using a
them using a
genetic
genetic
algorithm, which is
algorithm, which is
basically
basically
NSGA
NSGA
2
2
variant.
variant,
And
and
then we
then we
output the set
output
of
the set
Pareto
of Pareto
optimal points,
optimal
and then you
points, and then
can
you
do an
can do an
extensive
extensive
evaluation of those
evaluation of
Pareto
those
optimal
Pareto
points
optimal
and pick
points
the
and
one.
pick the one.
The
The
biggest challenge
biggest
here
challenge
is
here is
building up
building up
the core
the core
search
search
engine
engine
and the
and the
analytical
analytical
models,
models,
because you
because you
cannot
cannot
run
run
millions of
millions
different
of
neural
different
network
neural network
combinations on
combinations
actual
on
hardware
actual hardware
accelerator, and the
accelerator,
hardware
and the
accelerator
hardware
may
accelerator
not
may
be even
not be even
sometimes
sometimes
available at
available
hand.
at
So you are
hand. So
doing
you are
this
doing
in
this
a hardware
in a
software
hardware
code
software
design
code design
paradigm fashion.
paradigm fashion.
So
So
in that
in that
particular
particular
case,
case,
what we need is
what we need is
analytical
analytical
models of
models of
performance,
performance,
latency, energy
latency, energy
consumption, stuff
consumption, and
like
stuff
this. And
like
we
this.
have
And we
also
have
built
also
our own
built our own
in-house
in-house
analytical models
analytical
for the
models for the
GPUs, like
GPUs,
embedded
like embedded
GPUs, like
GPUs, like
Jetson Orin
Jetson
and things
Orin and
like
things
this,
like
as
this,
well as
as well as
also
also
some things
some
which are
things
running
which
on
are
the
running on
mobile
the
phones,
mobile
like
phones, like
M4 chip
M4
and
chip
M3
and
chip
M3
and
chip
things
and
like
things
that
like
that you
that
have
that
on
you
your
have on
mobile
your mobile
phones.
phones.
Having said
Having
that,
said
let's
that,
go a bit
let's go a
deeper
bit deeper
into the
into the
security stuff
security stuff
also.
also.
So we
So
have
we
built a
have built a
complete
complete
extensive ML
extensive
security
ML security
analyzer in our
analyzer in
lab,
our lab,
which can
which
actually
can
analyze
actually
the
analyze the
security against
security
the
against
serial
the serial
attacks, which are
attacks,
done
which
at
are
the
done at the
inference time,
inference
the
time, the
backward attacks,
backward
which are
attacks,
done
which
at
are
the
done at the
training time,
training time,
and the
and the
model
model
stealing
stealing
attacks, which are
attacks, which
done
are
at
done at
deployment time,
deployment
also in
time,
a
also
black
in a
box
black
setting
box setting
completely.
completely.
And of course, we
And
are
of course,
looking
we are
into some
looking into
hardware
some
security
hardware
things, but
security
I'll
things, but
skip
I'll
for
skip for
today's talk.
today's talk.
In general, we
In
know
general,
that
we know that
machine
since
learning,
machine
when it's
learning, when it's
going into
going
a
into a
decision making
decision
stuff,
making stuff,
it has to
it
be
has to be
robust.
robust.
Otherwise,
Otherwise,
you can make
you can
wrong
make wrong
decisions, and you
decisions,
will
and you
not
will not
know
know
exactly that why
exactly
it
that
was
why it
making
was
wrong
making
decision,
wrong
because
decision,
you have
because you
no
have
idea
no
that
idea
someone
that
has put
someone
up
has
the
put up
physical
the physical
environment,
environment,
and the data
and the
that you
data that
are,
you are,
let's say, using for
using for
computing is
computing is
actually
actually
poisonous data.
poisonous data.
So I give you
So I
some
give you some
example.
example.
Here we have
Here we
built
have
up
built up
a tool to
a tool
analyze
to
the data
analyze the data
sanity. So if you
sanity.
are
So if
using
you are
your
using
data
your
for
data for
training, you have to
training, you have to
ensure that
ensure
data
that
is a
data
clean
is a
data.
clean
It does
data.
not
It does
acquire
not
the
acquire the
samples. So we have
samples. So
done
we
a
have done
PC
a
based
PC based
analysis.
analysis.
So for
So
let's say
for
general
let's say
traffic
general
set,
traffic
which is
standard
data
which is
set,
data
which is
set which was
poison. So we can
poisoned. So we
see
can
that the
see that the
poisoning
poisoning
of the
of the
sample have a
sample have a
completely different
completely different
distribution compared to
distribution
the
compared to
clean
the
one.
clean one.
And similarly, we
And
have done
similarly,
it
we
for
have done it for
C4
C
talent.
for
We can
talent.
do
We
it
can
for
do it
the
for
more
more
advanced one. The
advanced one.
issue
The issue
happens where
happens
you
when
have
you have
bit
bit
disparate kind of
disparate
data
kind of data
distributions, where
distributions
you
where
have
you have
lot
a
of different
lot
type
of
of
different type of
classes, and there's a
classes and there is
feature
a feature
overlap
overlap
happening.
happening.
In those
In
cases,
those cases,
sometimes the
sometimes the
poisonous data
poisonous
can
data
have
can have
overlap, but
overlap,
then you
but
need
then you need
multi-tiered
multi-tiered
analysis to go
analysis
through,
to
and
go through,
only
and only
PCA
PCA
or ICA
or
kind of
ICA kind of
analysis won't
analysis
be
won't be
sufficient in this
sufficient in this
case.
case.
We built
We
up
build
a
up a
very big
very big
library for the
library for
serial
the
attacks
serial
to
attacks to
analyze the
analyze the
security
security
vulnerabilities
vulnerabilities
of
of
different
different
machine learning
machine learning
algorithms. Is
algorithms. Is
you can
and you
just
can
simply
just
see
simply see
security as a
security as
service
a
here,
service here,
and we have
and we
lot of
have lot of
state-of-the-art attacks,
state-of-the-art
and we have
attacks, and we
lot
have
of
lot of
novel attacks
novel
that we
attacks
have
that we have
developed in
developed
house.
in house.
I just
I just
show
show
you
you
some of the
some of the
examples of the
examples of
attacks
the
that we have
attacks that we
developed
have
in
developed in
house.
house.
This is
This is
a very
a very
powerful attack,
powerful
a
attack, a
patch-based
patch-based
attack on
attack on
monocular depth
monocular depth
estimation, which
estimation,
is very
which is
widely
very
used in
widely used in
autonomous vehicles
autonomous
and
vehicles
mobile
and
robots,
mobile robots
especially.
especially.
You can see
You
that
can
there's a
see that there's
small
a small
patch which is
patch which
put
is put
on this
on this
a person's
person's
back,
back,
and this
and
person
this
is
person is
not
not
very
very
clearly
clearly
visible to
visible
the
to the
autonomous
autonomous
vehicle or the
vehicle or
mobile
the
robot
mobile
now
robot
in this
now in
depth
this depth
estimation,
estimation,
or it is
or it
seen
is
very
seen
far.
very
So
far. So
if your
if
depth
your depth
estimation
estimation
is used to
is used to
calculate the
calculate
distance
the
between
distance between
objects in
objects in
driving, or
driving, or
then you can
then
see
you
that
can see that
this
this
object
object is seen very far while it's very near to you. Same we have done it for the car, same we have done it for the indoor slam and stuff like this.
So this is a
So this is a
video of the
video of
driving
the
scene, and
driving
you can
scene, and
see
you can
that this
see that
car,
this
for
car, for
example,
example,
is not
is not
detected
detected very well,
and this is
and this is
the
the
like the
like
real,
the
and this
real,
is
and
with
this
the
is with
attack,
the
and with
attack,
the real
and with the
you can
real
see
you
that the
can see
car
that
is
the car is
becoming
becoming
closer,
closer,
while
while
here
here
the
the
car
car
is
is
not
not
becoming
becoming
closer,
closer,
rather
rather
it
it
looks
looks very
far
far
for you.
for you.
This is
This
also
is
one of the
also one
very
of the
powerful
very
tanks
powerful
that we
tanks
have
that we have
demonstrated at
demonstrated at
CVPR like
CVPR
about
like
2 years
about two
ago.
years ago.
Victor,
Victor,
one
one
of
of
my
my
student,
students,
he
he has
has
implemented
implemented
this
this
attack
attack
on
on
the
the
person
person
detection
detection
systems.
systems.
You
You
can
can
see
see
is
is
that
that
he
he
has
has
printed
printed
this
this dog
dog
or
or
a
a
cat,
cat,
whatever
whatever
image
image
you
you
give
give
him.
him.
He
He
adds
adds
a
a
very
very
small
small
invisible
invisible
noise
noise
into
into
that.
that.
Whenever
Whenever
he
he
hides
hides
the
the
dog,
dog,
he's
he's
visible.
visible.
Whenever
Whenever
he
he
unleashes the
unleashes the
dog,
dog,
he's not
he's not
visible.
visible.
At that
At
time, the
that
state
time,
of
the
the
state
attack
of the
was that
attack
you
was that
have
you
to
have
stand
to
straight in
stand
front of
straight
the
in front of
camera,
the
but now
camera,
he
but
can
now he
stand
can
at
stand
any
at
angle.
any angle.
He can
He
create
can create
creases.
creases.
So
So
basically, what we
basically,
have
what
done,
we
we
have
have
done, we
modeled
have
different
modeled
type of
different type
refined
of refined
transformations,
transformations,
expectation over
expectation
the
over the
transformations kind of
transformations kind
stuff,
of stuff,
and he
and
has
he
also
has also
modeled the
modeled the
grease
grease
transformations, and he has
transformations, and he
modeled
has
other
modeled
kind
other
of
kind of
brightness and
brightness and and variations, and then integrated in an in-loop optimizer and generate a noise which can then be integrated into the given object. There is also one more model which is important here, because whenever you're generating a digital image and put it on a shirt, there's a color converter, so that kind of degradation effect is also included in this attack, which basically makes it very strong attack actually. And we are also working on the defense pipelines. I will skip that kind of part for today, but just give you an idea how a defense pipeline looks like. The defense pipeline works in many different ways. One that I showed is the data sanitization, so that is done for the poisoning attack. But you can also develop retrofitted pre-processing pipelines. Many of the dispersed noise attack can be removed using specialized noise filtering. Many of the non-robust attacks can be filtered using fine transformation and quantization. But then other kind of attacks can be detected or eliminated using post-processing kind of methods also, and this is what we have been actively looking into that. This is one attack that we have developed on dimension reduction-based attack, which we have developed for topic detection and classification problems. Here you can see there is a grand cam view of this image. So here there is a fish in the hand of a person. When we are dispatched, then the fish is not detected, rather something else is detected, and we know that the patch has created the focus on the important features somewhere else. So once we reduce the dimension reduction, we deploy the dimension reduction on the input space, then the the important features are being learned, and the focus comes back to fish, and it's selected as a fish. So there are a lot of these kind of things that can be done. Of course, every defense comes with a certain cost, and there is no single golden silver bullet here, or golden defense mechanism. You have to implement a multitude of defenses, because there are different philosophies of attacks that people are working into. There is attacks on the detection mechanisms. There is also this other stuff that we are working on is on anti-weather kind of forecasting. This is a full-scale detection and in detection system. Here is an anti-fogging system. We can actually clean up the fog, get the clean image. We are currently working on an extremely dense cloud fog. That's the second version that one of my team is working on. And then we can actually put this on a mobile phone, which means that it's weather filtering, detection, distance estimation, and quoting on a mobile phone, so that even if your car does not have this feature, you just simply install this app and then can start using it, like making your car kind of a semi-autonomous. It's more like a recommendation to the driver and stuff. While the upper system that you have seen is basically extremely robust in different lighting conditions and stuff like that. Now we are building up a multitask solution, which means that one single system can do all these tasks, because you cannot afford 10 different models on your mobile phone running in parallel. Having said that, we are also looking into other kind of security issues, like for example, there is a large language model based deepfake detection. This is the EdgeAI detection, where you can give a picture of a rose, ask is it natural or fake. It will tell you that this is a natural image, it's not a generated image, and it tells you the reason behind that. We have developed different model variants, and we see that the reasoning can change depending on the model quantization and stuff like that. And this dog, for example, is a AI generated image, and then there is a reason behind that. We are currently working on a very advanced version of this thing in an agentic format, which means we are building a forensic agent, and forensic agent can actually give you better reasoning and better detectors also. We have also developed an agentic system based on Quen to deepfake detection. This is a video and image deepfake detection. Currently we are working on audio stuff also, and then our goal is to integrate. It can give you reasoning, which frame has been manipulated, where it has been manipulated, and which kind of filter it has been manipulated, most probably like frequency domain or spatial domain filters. And then we can actually give you very robust answers for that. We are actively looking into large language models for jailbreaking also. This is a very important threat on the models. So earlier, as I mentioned, the serial attacks, backdoor attacks are more important for the deep neural networks like CNNs and transformers. For LLMs, the biggest attack is the jailbreaking attack, which basically means you ask a malicious question to any large language model, and and it gives you the answer which it is not intended to give you. So we recently have a triple AI paper accepted meta cipher, which is one of the latest and most advanced jailbreaking attack, and this is a learnable attack, which basically in modern age is that if you do a jailbreaking in, let's suppose, any state-of-the-art stuff, then it can learn in 1 or 2 months, and then it defines the guardrails and stuff like that. But we have a RL agent which can learn on the fly different type of ciphers, and it keeps on updating as the defense is also updating. So the whole idea of these jailbreaking attacks for us is to understand the vulnerable space so that we can design the guardrails.
थोड़ा सा
Some of the
Some of the
videos
videos
building up
building up the
just skip
just
through
skip through
these
these
kind of stuff, and
let me show you the videos of some of the stuff. This is a very nice project that we are building up, which is a mind controlled cognitive arm.
So we
So we have built up this complete thing in house, from mechanical components to all the way up to the intelligent components, for example, and the electrical components like the motor integration, controlling brain, controlling through gaze and stuff like that. So I'll just show you a video of that, which we showed in Make It in Emirates events, and it also got into national news.
And we are
And we are currently showing this in another exhibition today in Abu Dhabi also.
So
we are using it using, for example, DEC ultra cortex, but ultimately we want to extend that and use it, for example, like headset kind of based things.
So this
whole
all the
operation, the
operation
operation that we are doing is like my student is thinking, and then it's taking action. It can move the hand, it can make different operations like rest in bottle. It can look at any location, and the arm will move there. So this is a gaze-based kind of movement. There's a little bit latency because at the moment functionality is the biggest thing that we are making it perfect, and then later on we'll do the model optimizations for the no latency after in the second round.
So we have
now
this is
this is the second generation.
fourth generation
of
ARM, because currently we are optimizing the mechanical models mostly, and now we have the joint and the shoulder. For example, with full 36 degree of freedom. I don't know exactly the number, but it's a completely G1 compatible arm, like your G1 humanoid has. These are like different mobile watch. I already showed you that. I'll skip through that. This is an autonomous slam kind of demo where I can show you that this robot can completely do the slam autonomously, build up the map of the area. I think the more important stuff that I'm going to show you is this VLA, for example, this Limo. You can give the command to Limo actually text or voice, and it can do the task. There is no explicit programming of this thing. There are like four different machine learning models working on this collision avoidance detection, and a tiny VLM which is operating there is a grounding Dino actually integrated them and operated them. So just to tell you that what the different portion is doing is doing frontier exploration, mapping, path planning, and optimization. So this is the kind of stuff which can do autonomous reconnaissance for you. It can do patrolling for you. It can do also localization for you and things like this. Once this is functionally complete, we will also do the complete security analysis of that and make it much more robust so that none of these objects go evaded by adversary, for example, in your maps and things like that. Across the medical projects, we have worked on the medical projects for hand and ultrasound devices together. Healthcare, we are looking into the extremely compact model for X-ray detection. We have an end-to-end system for multiple sclerosis, brain MRI detection. We have a backbone based on different type of segmentation networks and detection networks. We are doing a lot of input pre-processing for data. We are working on a lot of metric evaluations and post-processing, doing a longitudinal analysis, and we are also building up a fine-tuned LLM to give you the answer. So let me give you just a very short demo of this thing. It's based on tiny lava mat, but we are now looking into more advanced models for this thing. You can see here is that this is running completely on Jetson Nano. You can give an X-ray image, ask a question, it can start answering the question. This is on the back end connected to a PubMed dataset, which is one of the largest datasets for the publications, medical publications. It gets you the answers
recommendation from there, and on the back end we are doing our own segmentation and things.
And this is
Another
another
government
kind of project where
we are
basically
extensively adding different type of medical data sets
for
for
simple
simple
queries that
queries that we will be having
regarding
regarding
medical
the medical
diseases or
diseases or
symptoms
symptoms
and
and
stuff
stuff
like
like
that.
that.
It
It
can
can
tell
tell
you
you
that
that
what
what kind
kind
of
of prescriptions
prescriptions
can be
can be
done.
done.
So these kind of
Tools
tools can be
can
used
be
by
used by
doctors as well as
doctors
the
as well as the
patients,
patients,
and this is what
and
we
this
are
is what
building
we are
up. This
building
is
up.
just
This is just
some of the
some of
results
the
of this
results of
laminate
this
project
laminate
where we
project
have
where we
shown
have
that
shown that
we actually
we
achieve
actually
better
achieve
accuracy
better
compared
accuracy
to
compared to
the
the
state of the
state
art.
of the art.
When doing the
When doing the
longitudinal
longitudinal
analysis, we have
analysis,
figured
we have
out
figured
that the
out
state
that
of
the
the art
state of the art
metrics like
metrics
dice
like
scores are
dice
not
scores
really
are
good.
not
So we
really
are
good. So
working
we are
on new
working on new
metrics for
metrics
this,
for
but this
this,
is still
but this is
like
still like
ongoing work.
ongoing work.
So I cannot
So
show
I
you the
cannot show you
results
the
until
results
we
until we
publish that.
publish that.
I think I
I
can
think I
stop
can
my
stop
talk
my
here
talk
because
here
I'm
because
already
I'm already
over
over
time
time
maybe
maybe
or almost
or
done.
almost
But
done.
we do
But
have a
we do have a
lot of
lot of
research in
research
quantum
in
machine
quantum
learning,
machine learning,
EDA for
EDA for
quantum
quantum
computing. We're
computing.
building
We're
up
building up
quantum
quantum
circuits. We're
circuits.
building
We're
up
building
noise
up
tolerant
noise
quantum
tolerant quantum
circuits.
circuits.
I have a
I
team
have a
of
team of
around
around
five
five
postdocs and
postdocs
around
and
10
around
student
10 student
RAs
RAs
who are
who are
extensively working
extensively
in
working
this
in
thing, and
this
we have
thing, and we have
published at the
published
top
at
tier
the top
venues
tier
like
venues like
IEEE
IEEE
Quantum
Quantum
Computing
Computing
VQAI
VQAI
and Top
and
Quantum
top
Tellers
quantum
this
tellers
year.
this year.
And the team
And
is
the team is
extensively looking
extensively
into
looking
industrial
into industrial
collaboration with
collaborations with
Thales
Thales
Pondela,
Pondela,
who are like
who are like
really
really
doing a lot
doing
of
a lot of
practical quantum
practical quantum
applications in
applications and
logistics and
logistics and
stuff like
stuff
that.
like that.
So I think
So I
I'll
think
conclude
I'll
that
conclude that
here
I would
to give you an idea
give you an
that
idea that
besides building up
besides
the
building up the
practical systems
practical systems
prototype, our
prototype,
team
our
has
team
also
has also
succeeded in
succeeded in
publishing at
publishing at
top tier
top
venues
tier
like
venues like
CVPR,
CVPR,
IIII,
IIII,
ICML,
ICML,
ICCV,
ICCV,
DAC in
DAC
terms of
in terms of
systems and
systems and
IDOS in
IDOS
terms
in
of,
terms of,
for example,
for example,
robotics,
robotics,
QCE, and
QCE, and
QSW in terms
QSW in
of
terms of
quantum.
quantum.
So with
So with
every
every
field, we
field, we
typically
typically
target
target
the state of
the
the
state of
art.
the art.
Of course,
Of
thanks
course,
to the
thanks to
team
the team
members, they're
members, they're
extensively
extensively
working day and
working day and
night,
night,
and
and
a lot of
a lot of
student
student
RAs who
RAs
have
we
been
have been
also
also
extensively
extensively
supporting us
supporting us
in initial
in
proof of
initial proof
concept
of concept
studies, in
studies, in
demonstrations. And
demonstrations. And
some students
some
are
students
really
are
very
really very
smart and
smart
they
and they
take the
take
work
the work
forward
forward
beyond even our
beyond even our
expectations.
expectations.
That's it from
That's
my
it from my
side. I just
side. I just
wanna pitch
wanna
you
pitch you
something which I
something which
think
I
every
think
year we
every year
might
we
be
might be
doing. We
doing. We
recently did a
recently
vibe
did a
coding
vibe coding
hackathon. A lot
hackathon.
of
A lot of
students from
students from
Pakistan and
Pakistan
Laos
and
even
Laos
actually
even actually
participated there.
participated there.
We will
We will be
hopefully
hopefully
organizing this
organizing this
hackathon next
hackathon
year
next year
also. And this
also.
year
And
we
this
did
year
it
we did
together
it
with our
together with
colleagues
our
in
colleagues in
Shanghai.
Shanghai.
The
The
winners also
winners
get
also
some of
got some
award, and it
award,
was
and it
very
was very
interesting
interesting
competition. We
competition.
got
We
like
got
more
like
than
more than
200
200
teams
teams
registered for
registered
that.
for that.
At every
At
year we
every
have a
year we have a
security challenge,
security
also
challenge, also
CSI event,
CSI event,
which is
which is
recently just
recently just
concluded, but next
concluded,
it
but
will
next it
begin
will
in
begin in
November.
November.
But then there
But
is an
then there is an
upcoming quantum
upcoming quantum
hackathon, which is one
hackathon,
of
which
the
is one of the
largest
largest
hackathon
hackathon
worldwide,
worldwide,
and this
and
is
this
the
is the
largest in the
largest in
MENA
the MENA
region.
region.
And I will
And I will
appreciate that a
appreciate
lot
that
of
a lot
students
of
from
students from
Pakistan also
Pakistan also
come and
come and
participate in
participate
that.
in
These
that.
teams are
These teams are
typically
typically
participating. So in these
in these
hackathons,
hackathons.
now I think
Now I
it's in
think it's in
April, so the
April, so the
nominations are
nominations
open
are
for the
open for
quantum
the quantum
hackathon.
hackathon.
So please
So please
participate in that.
participate in
This
that.
gives
This
you a
gives you a
great
great
perspective to
perspective to
look into
look into
challenging problems
challenging
at the
problems at
student
the
level,
student
build
level,
up the
build up the
teams,
teams,
interact with the
interact with the
international
international
students,
students,
and it's
and
in a
it's in
close
a close
vicinity, like
vicinity,
it's
like
not
it's
too
not
far
too
also
far
from the
also from
region,
the
so you
region,
can
so you
easily
can
come
easily
back and
come back
forth,
and forth,
and that's
and
also
that's
good, I
also good,
guess.
I guess.
I'll share the
I'll share
slides.
the
You will
slides.
get
You
the
will get
link
the
of
link
all
of
these
all these
contact
contact
persons, and then
persons,
you
and then
can,
you can,
coordinate with
coordinate
them.
with them.
Thank you very
Thank you
much
very
for
much for
now.
now.
I'll
I'll
stop
stop
sharing my
sharing my
screen,
screen,
the
the
slides, and if you
slides,
have
and
any
if you have any
questions, feel
questions,
free to
feel free
ask
to
me. I'm
ask me.
here.
I'm here.
Thank you, Professor Dr. Muhammad Shafiq, for delivering. We are not taking question answers from the audience because of your tight schedule. We sincerely sincerely thank Dr. Shafiq for sharing such a wonderful and inspiring talk with us. Thank you, and Allah Hafiz.
Thank you very much.
Assalamualaikum, Professor. Dr. Asif is here.
Okay, now ladies and gentlemen, session 1 has now concluded. We will now move on to the 3-minute thesis competition. I hand over the microphone to the 3MT team to begin this exciting session.